Hello, water managers and SWMS users. I'm Russell Errett with the Water Management Systems Division of the Hydrologic Engineering Center, and I'm covering HEC-ResSim within SWMS. So this is the third part of a multi-part video series to cover this presentation, so if you want to see the first two parts, check it out in the playlist. We've covered why we use HEC-ResSim within SWMS for real-time reservoir decision-making. We've done the introduction to HEC-ResSim, what HEC-ResSim is, what it can do, and why we want to use it within SWMS. We just covered going over how to integrate HEC-ResSim within SWMS, within the CABI itself, how to import and link HEC-ResSim. And so now we're going to go through using HEC-ResSim for real-time decision-making. So we're going to go through the data considerations, how real-time modeling differs from planning studies, and then we're going to go through release overrides later on using the operation support interface. So using HEC-ResSim for real-time decision-making, as we've talked about in previous presentations for SWMS real-time, you're going to want to review the data. So one of the things you want to do is check the data itself, like data status summary report. You hopefully have one set up for checking reservoir elevations and outflows, which are critical for HEC-ResSim to run. So check those reports out to make sure you don't have any missing data. As we've covered, HEC-ResSim needs all the data and gets very upset when it doesn't have all the data if there's any missing data. So check those, make sure you have no missing data. Try to validate your data up front. That'll save you some time when you're doing the modeling. And then also, obviously, as we've covered within the CABI itself, just check the basin conditions. Understand what the basin conditions are. Is the condition wet? Is it the weather going to be more rainfall? Checking out the precipitation, whether it's going to be snow or liquid precipitation. These will help you understanding what's going on in your reservoir system when you're operating it, when you're trying to figure out the system operations. Hopefully you've done this when you did your HMS or hydrology calibrations, so you should have some idea of that, but this will help you understand where you think the reservoir is going to be going, what kind of outflows are coming out of the project, why outflows might be constrained if you have downstream control points downstream and there's a lot of water downstream, so that'll give you an idea of why rules are being activated if you understand the basic conditions up front. And then obviously select a appropriate forecast time window. We covered this in an earlier presentation, making sure that you have the appropriate look back window and a forecast time. So understand what you're doing to forecast for. Is this a flood forecast that doesn't need as long of a window? Is this a forecast that does need a longer time window? Is there multiple events that are going to be in the horizon? You want to forecast multiple events or those dual peaks if there's multiple rainfall events forecasted. Is this a drought forecast? Are you trying to figure out a water supply or trying to evacuate flood storage for a long period of time to see when things will open back up? So think about those when you're trying to come up with an appropriate forecast time window. So once you've reviewed the data, we've selected the appropriate forecast time window, you want to create a forecast. You want to use that forecast time window based upon what you were thinking. So hopefully you've thought about this before you did your HMS runs, but think about when you're selecting your time windows for not only the hydrology, but also for what you're going to do for reservoir operations. So we've talked about this earlier. Generally, I always like to say, whenever you're doing this, to select 2 forecast runs, one with no additional rainfall, so just basically what kind of water is on the ground, what has occurred in the past, observed precipitation, and then another run that has forecasted rain. It doesn't have to be all the forecast rain, it can just be the next 24 hours or maybe the next 48, 72 hours. Just put some type of future rainfall. And so I always like to liken it to, if you do the no future precipitation, you're drawing the floor. Like this is the bottom, this is the best case scenario, and then when you add additional rainfall, you can see the difference between those two, so you can understand how much is going to be coming in the forecast horizon. And then any additional forecast or time window offsets you need. So if you're trying to, if you have daily time series mapped to your HEC-ResSim model, and you're running it in an hourly time step, HEC-ResSim will do an interpolation, but it needs data points to do the interpolation. So if your starting data point and you're starting your simulation doesn't have a data point far enough before the simulation to do that interpolation, you might get errors. So think about that when you're doing offsets. You might have to offset an extra day before you start a simulation, and even at the end, depending upon what kind of extract time series are dependent upon it as well. And then compute all your models through HEC-ResSim. And what we mean by that is compute through NetView, HMS, into HEC-ResSim, so that everything's computed all the way up to that point. So whatever dependencies of models or extracts are done through HEC-ResSim. And so once you've computed through HEC-ResSim, there's multiple ways of viewing the results. There's obviously the standardized plots. There's reports. You can customize these to meet your needs. And then there's an operation support interface. There's also ways of view plots from within there as well, which we'll cover here later on. And then make modifications to your HEC-ResSim model as needed. So they might just be simple release overrides, or maybe there's just physical rules you want to change. Maybe the max releases are too high constantly and you want to curtail them down lower. Maybe there's a deviation you're trying to get. So you want to analyze a different maximum that needs to be in there because you're trying to analyze what the impacts of that deviation might be. Maybe there's different zones. You want to raise or lower a certain zone to see the impacts of that. Maybe there's some physical parameters. Maybe there's a gate blockage. So you want to, maybe there's 2 gates on a project, for example, and you want to, reduce it by 50%, meaning 1 gate is blocked, and see what the results of that are. So those could be things that you want to look at. These could be one-off things. So remember, you're running it from the modeling tab, and we've copied the models from the base or from the setup tab to the modeling tab. So it's a copy of that. So you can do all of these things in here and you just leave them in the forecast and never have to save them back. So it'd be one-off. Or maybe these adjustments are permanent adjustments. You're trying to update rating curves. You're trying to update maybe some of the physical parameters that have changed. Maybe you've got some new gate curves that you want to add to it. Maybe there's some physical things you need, or some rules that have adjusted that you want to have permanent. That would be an opportunity to save it back to base. And you would do that so that it's available for your future forecast runs when you create new forecast runs. Again, as we've said earlier, talk to your office, find out what the policies are for save back to base. There are offices that don't like to save back to base. Maybe these changes need to be set up in the setup tab or made in the setup tab itself and not saved back to base. And there may be somebody else maintains your SWMS models themselves, but there is a way of saving them back to base, and there's reasons for that, pros and cons to that. But check with your office for that. So tools for analyzing results. Again, we have standardized plots, release decision reports. I like to look at the plots and release decision reports together because sometimes one without the other is kind of hard to process. And I'll show you kind of a screen grab of what that would look like. Standard reports you'll get from the reports tab within the CAVI. And you can also just simply grab the results from SWMSview or DSSview. So if you wanted to just go and just look at the data from DSS, we can go through and filter by the F part and find all of the data that's been exported from ResSim. So I'm recycling a slide from an earlier presentation, but it's very applicable. So if you want to look at different results, there's ways to get to them. So you can expand the ResSim model from the modeling tree under your forecast run alternative and get to any of the elements. So if we wanted to look at one of the reservoirs, you can right-click and get to the plots from there. You can go into the map window, the map schematic here, and go and get to the reservoirs and do plots and get to edit properties, do release decision reports. You can get to different plot reports from there. You could also go to the reports tab down here and look at the reports that are available down here. And then if any of these don't seem like you want to use it and you're very familiar with a ResSim in its native environment, just crack it open from the ResSim in its native environment and you can get through all the menus through there as well if that's where you're comfortable with. It's very similar to like HMS if you need to get into the same menus and you're familiar with the model itself in its native environment, open it up from there. And then also in the end, there's a lot of results that are written out to the forecast.dss file, so you can always crack open SWMSview either from this icon here or from down here on the Actions tab. There's also a forecast DSS file, and open it up and filter by your F part. And your F part would be, for this example, would be 00H0Z0. That would be the ResSim results. So anything that has that F part in there are going to be all the ResSim results within there. So there's multiple ways to view results. So a standard reservoir plot, this is what a standard ResSim reservoir plot is. If you've not seen ResSim, this is what you would see if you cracked open a reservoir plot from ResSim. And so what you're seeing here is up on the top is pool elevation. So we have a pool elevation plot for the look back. So this dash line here, this is the look back time. And then this is the forecast time. This is the simulation period here. So all of this should be observed data and off to the left. On the right is simulation. So it's using the algorithm of the rule stack to create this pool elevation plot based upon its outflows, which are down here at the bottom. So down here we have all our flows. So we have inflows, which are in black, and then this outflow that's well below the inflow, holding back flood storage. You can see the pool elevation going up with that. And then over here, it's doing its algorithms to determine the outflows. Things to notice on the pool elevation plot: these purple dashed lines, these purple dashed lines here, are the zones in the reservoir. So this would probably be the top of inactive. This is probably the top of conservation or bottom of flood control pool. These are probably other zones within there. This could be top of flood. This could be the top of surcharge. This could be top of dam, depending upon how the zones are defined. So you can see there's 1, 2, 3, 4, 5 zones. And so this pool is operating within these bands here. So this is the bottom. So this zone is where all of the operations are occurring. So if you're trying to figure out what rules are being applied, this dashed line here to this dashed line here are the rule stacks you want to look at and analyze for the release decisions that are going on here. So a standard junction plot, this is what a junction plot will look like. So all of your junction plots will have the simulated flow, which this one has a solid red line here. The other thing that's very powerful, there's actually two flows, there's two alternatives that are being run through here. But what you'll notice is that there's this line with these shapes on here, the triangle or the circle here. This is the cumulative local flow. And what the cumulative local flow is very powerful for water managers. This is the cumulative flow downstream of your reservoir, meaning that if you just shut the reservoir off, you had nothing coming out of it, this is the water that would exist in the watershed that you don't have control over. So this is very powerful so that you know how much you could cut back to help regulate and how much you have capacity to open up to. So it's a really very cool time series that's computed within HEC-ResSim. This junction plot here is actually a downstream control plot, and the reason I know that is because this hashed line here, it has a line at 8,000 and it's hashed here. This means it's a downstream control point that doesn't want to go above 8,000. So HEC-ResSim is trying to make sure the releases do not go above 8,000 for this downstream control point. So what you can see is that we are basically almost either at zero or at a very minimum release on top of the cumulative local until we get to here, and then the reservoir starting to open up. And so the difference between these two lines is the reservoir release upstream. So very powerful plots to look at to kind of understand what's going on in the watershed and why the reservoir might be operating in a certain way. So then the reports tab, when we look down the reports tab, there's also these additional reports we can look at. So there's a reservoir summary report. This is a really cool report. If you're familiar with like HMS, this is kind of a similar to an HMS feel. So for each of the reservoirs, we have an average, maximum, and minimum for each of the forecast runs that we've done here. So there's different forecast run alternatives that are in here, and you can look at them in this forecast tree. So for this one that's here, we have all the summaries for each of the two reservoirs for this watershed. So this will give us the maximum storage, the maximum elevation, like the peak elevation, the max release, like the peak the release, and then if there's any uncontrolled spillways. So there's actually per outlet too. So if there's Tanner gates, sluices, spillways, it'll list out all the outlets that are associated to it. So this can be a very powerful tool to give you a quick summary. So again, that's a reservoir summary report. Very good, very powerful to get you some quick summaries. It could get you something to put into a briefing slide. Some other summary reports that are very beneficial. There's the reservoir summary report, which we looked at. That's available for any routing network that has a reservoir in it. And that might sound absurd, but you can create a routing network in HEC-ResSim that has no reservoirs. It's just routing flows. So then in that case, there would be no reservoir summary report. Probably more than likely, everyone that's using HEC-ResSim has a reservoir in it, so reservoir summary is going to have something in it. The flow summary report is available for all networks. So all HEC-ResSim routing networks are going to have a flow summary report. Otherwise, it's not a model. So the flow summary report is going to give you, per junction, it's going to tell you what the regulated flow is, the unregulated flow, and then the cumulative local flow, average, maximum, minimum, for each junction that's in there. And then the other reports that are in here, if you have a power summary, that will be available if you have a hydropower project. So if there's a hydropower component to your model, you can get a power summary report from there. If you've defined gate curves for your project, so if you have Tanner gates or sluice gates and you want to know what the gate openings are equivalent for those flows, there's a gate summary report that'll give you that information. And then there's a stage summary report, which is very similar to the flow summary report, but it's available if you have defined a stage discharge curve at a junction. So you can see in this stage summary report, these junctions have stage discharge curves associated to them. So if you're kind of crosswalk, you can see the flows for this Ramsey gauge for this watershed. You can see the equivalent for the stages that would be associated to that because of the stage discharge curve. So this can be very powerful, very similar to your reservoir summary reports. So check those out. Those are very powerful and can leverage to help you regulate your watershed. The release decision report. I find sometimes looking at the release decision report, which is on here on the right, by itself can be kind of hard to decipher what's going on. And so this is an example of a watershed where the release decision is being made on a daily time step. It's not being made every hour. So you can see a lot of the hours don't have a lot of things, but at 1500, for example, this is when release decisions are being made at this reservoir. And so in this reservoir, it's saying, okay, there's guide curve max limit, and then the active rule is a maximum release. So it's moving towards a maximum release for this time step. So from here to here, it's going from 1291 to just almost 1600. And this is the maximum release for that project at that time. And if you look over here at the plot, it makes more sense. So on the 10th, I'm trying to figure out why is it opening? And why is it only opening to this threshold? Well, the reservoir is going up, we have an inflow event coming in, and it's going up, and why doesn't it open up more? Well, it's because it's reaching a maximum release constraint. So sometimes a report by itself can be very confusing, but if you marry it up with another standard ResSim plot, it starts to make more sense. So this is where you can start to customize some of these reports and say, okay, I want to look at a plot, maybe I might want to look at a downstream control junction, and then I want to look at the release decision report as well. So sometimes when you look at these, you want to look at one and not just one by itself. If you have any questions about our software, need some help, or are looking for additional trainings, check out the links here, and they're also available in the description below. Thank you for your time.